There it is. Yep. Okay. Those are the notes from page 346, part A. And if you haven't watched that video yet, why are you here? Go back and watch that video. Have these note cards, 30, 60, 90 triangle theorem, where we have the relationships of the sides across from a 30, 60, 90 triangle. Have a 45, 45, 90 triangle theorem card, where you've got this relationship here on the back of the card, because that's the math that we're practicing. We're going to do some algebra calculations, some equation setups and solving. Our vocab word from the last video was distributes, but you should also know that there are times when you're going to need to combine like terms. This video, no combining like terms, but we will be doing some cancellation, some properties of equality like division. Okay, let's take a look at page 346, the bottom half, where we're going to work through the unknown sides of a figure. Now, I'm gonna at least annotate the worked example. All right, so not that. This would be a little smaller. There we go. That's background noise right there. Okay, here we go. Okay, you have a highlighter, you have a pencil, you have things you need to use. Determine the unknown side lengths and then rationalize the denominators. So there's a setup in this problem that they don't show right away, but I do want you to identify, you have only two note cards you have to figure out. Are we looking at a 30, 60, 90 triangle in this problem? Or are we really looking at a 45, 45, 90 triangle instead? And it's this one, right? I'm saving the actual answer for last. So the relationships used in this problem, the setup to get the value of x, is going through all of this. So like up above, I'm going to put the 45, 45, 90. And then I'm going to put what the bottom row is. The 1, 1, square root 2 will come back when I want to talk with you about trig. But for right now, I'm just talking about solving equations. So a, and a root 2. Those are lining up. Now, I use my highlighter, right? So I'm going to highlight just to make sure, again, when you have done at least 10 of these problems successfully, then you can stop doing the highlight. Then you can really, I think, move away from saying, yeah, this is a necessary step. But until you've done at least 10 of them, you're kidding yourself if you're going to be successful. Okay. X should line up with the 45. Y should line up with the 45. 11 should line up with the 2 root 2. Okay? So since that's how they line up, this becomes an equation. We got to figure out what A is. And you might start seeing the pattern, right? That's what I'm saying. After 10 or so experiences, you can jump right to what's on the paper. But if you haven't done like 10 of these, no, you're fooling yourself. Okay, we're going to say this means 11 equals A root 2. And we're going to solve for A. We're going to, cancel. We're going to divide both sides by square root 2. And when we divide by the square root of 2, we actually do end up with x. It's 11 over the square root of 2. A and x. A is just because it's on the note card as a generalized unknown value, but in the example, it's x. So A and x are in the same spot. Y is in the other 45 to A spot. It's this fraction that really is the right answer. 11 divided by the square root of 2. Now they're doing a rationalize the denominator step, so that's what's happening here. We've rationalized the denominator. Whatever the bottom is, you multiply that same square root, bottom and top. Notice bottom first, then the top. And combine. When you have root 2 times root 2, you get 2. The square roots cancel. That leaves us with this value for x. And y is the exact same thing. X and y are on isosceles legs of this right triangle, so therefore they match. So we don't have to do any calculation for y. We already did when we calculated x. It's the same answer. Pretty neat working example, right? There's a rationalize the denominator step. There's the write this process out. And so let's practice that. That's the goal. You should have some scratch paper because there's not enough space in the math book to actually do the work. Although we will do the work on scratch paper and I'll bring it back like the answers to this problem. I'm thinking ahead right away. I think this is 8, which means I think this is 8. And I think it's 8 because this is 8. But let's do the math to prove it. It's a 45, 45, 90 triangle theorem. So I'm going to use the relationships of a, and the square root of 2a from the 45, 90 situation. Okay. 9a, labeling my paper. And I'm going to do this. 45, 45, 90, a root 2. Highlight, 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 highlight. Okay? They need to match. So I'm going to take this 8 square root 2, and I'm going to put it in line with the 90. I know that this should be highlighted green because it's across from the 90-degree angle. It's always about where the 90 is, and then the side across from it goes with it. So I'm going to put 8 square root of 2 in line with 90, which means that there's an equation here that will help me figure out what a equals. So I'm going to make that equation be visible. I'm going to write a square root 2 equals 8 square root 2. Hope I'm enunciating clearly. A versus 8. Now to get rid of the number that's multiplying this letter A, we have to use division. So divide both sides by the square root of 2. Turns out the square root of 2 divided by the square root of 2 is 1. And then on the other side of the equation, you could rationalize the denominator. That would work. However, what's the square root of 2 divided by the square root of 2? 1. So they cancel. And like I said, A equals 8 because it's what's left. Since A equals 8, I can put an 8 here. I can put an 8 here. That question's done. Let's go to part B. Why don't you maybe like pause and you do part B before you see me do part B. So put a pause in the video. I'm going to work through part B now. Okay. I don't really want this to be visible. I'm going to fold my paper, I guess, a little bit. Okay, here goes. 9B. I have a 45, 45, 90 triangle. Move the camera over a little bit. And then I'm going to write A, and A root 2. So then I'm going to take this. Oh, wait, this is orange, right? So orange, 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 orange. Green, green. Orange, you glad I didn't say green again? Now, let's see here. 3 root 2 has to be the same, right? Both of the sides on the orange have to match, which is why I put 8 in 9A. Because this is a 45, 45, 90 right triangle, the sides across from the 45 degrees, there are 2 of them, those 2 sides are equal. That's not true in the 30, 60, 90. There's a different relationship in the 30, 60, 90 that we'll talk about after this part. Since 3 root 2 is A, and 3 root 2 is the other A, that means we have an equation where A equals 3 root 2. So we're missing the unknown hypotenuse of this triangle. But because the relationship between 90 and the side across from it is A root 2, then I'm going to take this whole A value, all of it, 3 root 2, and I'm going to substitute it for A in this formula. So then here's my next part of this entire problem. X equals 3 root 2, that's the A part that I'm substituting, and then the root 2 at the end needs to go outside the parentheses. There has to be 2 root 2's. There's the root 2 from what A equals, and there's the root 2 because there's always a square root of 2 in the 90 hypotenuse. But sometimes, depending on our choice for A, it'll cancel out. Remember what I said. What's the square root of 2 times itself? We've done this with all of our rationalizing the denominator problems. When you rationalize the denominator, you multiply the square root times itself. That becomes the number that's inside. In other words, x is actually 3 times 2. 3 times 2, 6. All right, I'm going to say F is free. Well, no, I'm going to do letter F. I'm going to skip around. I'm going to try to make this video all about 45, 45, 90 triangles. So the final video will be about 30, 60, 90s. F, this shape along the bottom, right? F is this square shape because that's how a 45, 45, 90 triangle is created. You cut a square in half. In that square, let's see here, another fold. In that square, they are pointing to us knowing the hypotenuse. So we know green, we have to go calculate orange and orange. Okay, actually I'm going to leave it with that because if we know the hypotenuse, then we actually have exactly the first example that we did. We knew the hypotenuse was 8, and that told us what the side lengths were. So no, I'm not going to find your value for F. You need to. You can check with me after it's done. Those are the 45, 45, 90 degree examples. Have your notes, have your work. You're going to have to show work. So like put that paper in this book and like attach it. You need to have the work for these problems. Stick around for part C, I guess, of the video that we're in. Thank you for watching this one. Next up, 30, 60, 90 triangles.